Hey everybody, this is Larry. This is day 14. Oh, yeah, that's right. Happy Valentine's Day, everybody. Hope y'all enjoying it or whatever. Yeah, hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. No updates on the leg. I mean, it's probably slightly better, but I'm still wearing a cast, so I don't know. Don't have much to say about this weekend. Hope everyone's having a great just weekend or whatever whenever you're watching this. Um, yeah. The month is half over. Hope everyone's enjoying it well. And yeah, let's take a look at today's farm. We have 1352, product of the last k numbers. Okay, so design an algorithm that accepts a stream of integers and retrieve the product of the last k. Okay, I mean, the first thing to note is that we probably only need like a sliding window thing. I think the other thing is just to kind of the only case, and they kind of give it to you actually. I was going to say, I was going to look for it, is that 0, right? Oh yeah, I was already going to try to see if I could do an O of 1, but yeah, but 0 is a big one, right? Because it converts it to 0. Because okay, so how would we do it without zeros? Let's maybe start with that. And the way that you would do it without zeros is, well, you could think of it as a sliding window, right? So you're looking at you're looking to keep k numbers, so then you when you add one, you also remove one, and you add one by multiplying, you remove one by dividing, right? And you can actually think about this in terms of logarithms if you like, because then I don't know if it's easier. It may not be easy if you don't not really comfortable with logarithms, but the idea is that, of course, if you multiply two numbers, it is the sum of the logs, right? And that part, okay, right? You have to be familiar with that part, like I said. But after you after you kind of make that transformation, then you could do the proof of that. Okay, well, and it just becomes adding and subtracting, which maybe you've done more problems with, right? Maybe not, but these are the ways that I would think about. Maybe you're watching this and be like, why is Larry talking about this? This doesn't, like, I know how to do product and dividing and all these things. It's just that, for this problem it may not matter, but it's just that when you build up all these like toolkit, I would like to call it toolkits, and maybe even analogies, then you're able to kind of transform every problem into a different type of problems, and then maybe you can solve one of them, right? And that's the thing. The end of the day is that you don't need to solve this like in 8 different ways for an interview or a contest or something like that. You only need to solve it once, and so you're able to kind of transform it in some way that allow you to solve it, and the code may not even look the same. It's just the thing about like in your head about visualization and thinking about it, right? And you're able to do that, then allows you to kind of get through whatever block when you're stuck, right? All right. Anyway, sometimes you need it, sometimes you don't. But I don't know. I just want to bring it up. Anyway, okay. But the problem with that, of course, with the logarithmic stuff and the logarithmic of or just product stuff in general, is, as we talked about, the 0, right? Because once you add a 0, it's almost like one of those irreversible things, right? You multiply 0, but then you can't divide it by 0 when it comes out, because so how can we do this? I mean, there are probably a couple ways to do it. I don't necessarily know like what the best way is, and I don't know. I mean, I think I don't really matters that much, but the idea though would be that we just keep track of zeros, right? And I think that's really it, because they're really only these are the things that you may be thinking about in terms of just keeping track or thinking about what states mean. And states are just kind of or maybe states is one way to put it, but what I may even kind of consider calling it is something called a congruent class, right? Which sometimes for sure, sometimes people conflate the two, and maybe they are. There are a lot of things you can do that, right? Because you're kind of like but with the equivalence class. But I think like from that, then you can kind of maybe do a case analysis on what that means, and I think that should be able to allow us to get it. Yeah, and part of that, of course, is this idea of invariance that I talk about a lot on my channel. But yeah, so okay, so with the sliding window part, we do want to say, yeah, let's just put it in a queue right? And then maybe zeros. I always forget where zeros have. Does zeros have a year or no? I always get confused. Man, I am really bad. Okay, 0, 0, and then the current what's it called? A product. I don't know why I couldn't find. I was gonna say the multi something, and I was like, no, it's literally on the title, product, right? But yeah, I don't know how. Oh! I messed up. Sorry, I didn't realize that. I mean, okay. For some reason I thought that K was constant, so I kind of messed up here. Okay, so we have to think about it a little bit more then, huh? Okay, my apologies. I misread. I mean, I think what I said about the ideas are still kind of true with respect to kind of thinking about it. But of course, we have to think about it a little different way. So if you watch it so far, maybe that's like a bonus thinking thing, because then now we have to do another thing. Okay, so let's think about it again. Almost restarting the problem. My apologies again, because I actually, for some reason, I didn't realize that K would be K would be a variable. I just thought that'd be like for a fixed K. Okay, I mean that's fine. How do we want to do it? I mean, it is a little bit easier in Python, just because because you can use big num, right? Which I don't know. Maybe it's fine. Maybe it's not. I don't know, right? And of course, if you're really fancy, you know that this is true. You can do like a modular inverse thing as well, I think. I think that is true, because if it doesn't overflow, that means that it is, well, now you can do a modular inverse where it's 2 to the 31 over, that's not a prime though, right? Like, is that a prime? Is it a prime or not? Huh, it is a prime. I always, I mean, I know that I get confused about the Mersenne price. So you can do that as well if you really want to play around with number theory with using modular inverse. What is the right way to do it? Honestly, not quite sure. I mean, I think one thing is that we can maybe take advantage of is that this is 100, right? So what I would say is that so I mean, this one is a little bit trickier now, but it's still not, you know, too bad per se. I think the key thing to notice is that you know, you only have a 32-bit integer, right? Like I said, you could do like some prefix, some idea of doing modular inverse and stuff. But the thing about it being 32-bit is that there are only now in this case two special things, right? One is 0. Kind of talked about. If I have some idea, we'll go into it more when we get into code. For now, it's just like, you know, if any whatchamacallit, if any subarray has a 0, then it's gonna be 0, right? That's straightforward. And then the second thing is the number of ones, right? Of course, if you have ones, then your number just don't get bigger, right? Also, pretty straightforward. It is what it sounds like, right? I mean, you're aware of identities and under multiplication and ones and all these things. No, I don't think I have to go into it in that much detail. But in terms of implementation, what that means is that if you don't have zeros and you don't have ones, what does that mean? That means that at worst you only loop 32 times, right? So that is one way of not needing to do some funky prefix something, right? Though I guess I was going to do something like with binary search, because then now you could just search for you know, the first thing. Yeah, but I guess, well, okay, the other well, I was gonna say binary. Oh, I guess all of K. They expect you to do all of K complexity. I guess that, I mean, all of K complexity would be obviously just very simple, right? But in any case, yeah, I guess, yeah, I was gonna say with binary search you can do it, but of course that's also gonna be log of n, right? Where n is the number of numbers. So that's not quite O of 1. I mean, the prefix sum idea is O of 1, but I don't really, I feel like that is possibly whatever, but maybe that's fine. I don't know. It's an awkward problem for sure. Oh, huh. Huh. I guess that's something that I was looking at, but I was willing to exploit. Because then now you think about this form is just annoying, honestly. Because then it just means that, okay, well, what does that mean, right? I think the thing that I was talking about and framing it is with any subarray, which is, you know, fine. But in this problem, you only need the last k, right? So what does that mean? So that's actually a little bit different from. That's a little bit different from. The honks outside. That's a little bit different from any subarray, right? Because you only need the last k. Because then now, what does that mean, right? That means that if you see a 0, everything to the left of the 0 you don't have to worry about anymore, right? So oops. So that, at the very least, that means something. And because of this thing, like I said, there'll be at most 32 numbers if you don't count the ones. So then now, in a way, because of this, I mean, I was actually, when I pointed this out earlier, I think I was meant that 32 is the number. Oh, sorry, the 32 bits is the final result is under 32 bits. But here is actually the product of learning contiguous. That means that you are able to actually keep track of, yeah, that means that you can actually keep track of more than anything, right? Because then now you could do the division thing, though I don't know. I mean, you could do it that way. I don't think there's anything wrong with that. It's just that I'm gonna try something funky. So let's you know, bear with me. So then here we will still use a deck, right? Maybe, right? So that's the last whatever items, right? And then now, okay. So we want. Well, if we say it's 0, then, you know, like, we don't need to record zeros anymore because everything to the left of the 0 is gone, right? So we can, but one thing that we want to do is to keep track of number of ones, because the reason why we want to keep track of number of ones is that because I for now do not want to put them in deck, because then if you loop over the deck it'll be too long. But here, if it's only 1. If you skip the ones, then, as I said, then you can only need up to 32 numbers with no zeros and ones, right? And that's really the idea, I think. Okay, so if there's a, well, you need to keep. No, I mean, I guess not. Yeah. Here, then I go to that append num, right? Oh, well, if num is equal to 1, then self dot ones is increment by 1. Yeah. Kind of did it. If num is equal to 0, then actually we clear out the queue, right? Because nothing to the left of it matters. We clear out the ones, right? Yeah, and then we return, I guess. Goes to an else. It doesn't matter. Yeah. And then otherwise we do this, and that's it, right? For the add. Hopefully that sets you an idea of what I'm thinking of. And then get product. Yeah, I think I'm actually not sure about this, only because, well, I was gonna say I'm not sure about if I could do this, because I'm not sure that it makes sense that this is an O of 1 per iteration. But even if it's n squared, it's not a big deal, because, like I said, this queue would only have at most 32 numbers, right? So we should be fine. But okay, so we check if there's a 0. If there's a 0, that means that we don't have enough numbers. I assume k is a valid thing, but yeah. So basically, if length of self of q plus self.ones is less than k, then we would just return 0 because we don't have enough numbers. That means that we've seen a 0 more recently. Otherwise, then yeah. And actually, does it have to be a deck? No, the way that we do it, we never put pop, right? So actually, I lied. Then this should be a stack. And maybe that's a kind of like a thing that I would say is that you know, even I'm wrong on some data structure sometimes, clearly, right? So yeah, because and we don't even remove anything from the we don't ever. I mean, I call it a stack, but I don't even know if that's accurate. Because we don't remove it from anything, right? Like the only thing we do is we reset. That's the only thing we do. So I don't even know if it's a stack. Is someone in a stack, and that now we go backwards? But I think I'm wrong on this one now, actually. See, like I said, I make a lot of mistakes because then now. Oh no, I mean I think it's fine. It's just that we have to keep track of the indexes. Of the zeros and ones. That's what I forgot. Yeah, okay. I mean, but yeah, what I was gonna say is that because if you don't, then you know that stack plus the size of the stack and ones are greater than or equal to k, but you don't know what the composition is, which is why this is a little bit awkward. But yeah, so maybe we just have like a counter thing, right? And then here we always increment, right? Say. And then when we append, we just append it with the counter. And then now we just go from, you know, so we go from the top of the stack. It's not even a stack, it's just an iterating thing, right? So we have start with index is equal to self.counter, or not index. But the index is not the right one because self.stack, right, of yeah, basically maybe like for index in range from self dot or length of self.stack -1, -1, whatever, yeah, counting downwards, right? So we have this thing, right? This have two things, the x and the counter, which is the I don't know, C for counter maybe? I don't know, right? So then we have self.counter is the current counter minus, I may be off by 1 on this, right? So if this is greater than k, then we return the product, right? And of course product we start with at 1. And then yeah, and then otherwise product times x return product, and I think that should be good. Maybe not, but am I close at least? Okay, I mean, like I said, maybe I'm off by 1, which is fine, or like easy to fix, right? But I just want to double check. 5 times 4, so okay, so it wants the last 3 numbers. Oh no, I'm getting wrong the 2 numbers. 2 numbers is 5 times 4. Okay, so let's see, let's take a look. Like I said, I'm just off by 1, which is, I don't know, it's fine, maybe not, I don't know. I don't know why this takes so long. Is my internet issue? Okay. So yeah, so this is the stack, right? And oh, maybe self.counter. So we have 5. So yeah, so this means that it has, so we're here, we do this number, but we count it as 0. So then now, yeah, so I'm just off by 1. Okay. I mean, there might be other issues, honestly, but at least that, right? And these things are always kind of, at least for me, sometimes tricky. But yeah, let's give it a submit. Yeah, I mean, okay. I probably didn't do it the way that normal people do it. I think prefix sum is probably honestly the reasonable way to do it. But I just want to try something new, honestly. I figured I could make sense of it. So what's the complexity here, right? It is technically all of one as well. I mean, this is all of one. This is all of one. You know, the only thing that looks wonky is this for loop. But as I said, this is I don't know, O of one in the sense that if you want to be really precise, it's probably O of B, where B is the number of bits, which is 32 because that's number of things in a 32-bit integer, and that's what they guarantee, right? So it should be fine. And because we skip the ones, it won't be anything more than that. But yeah, that's all I have for this one. Let me know what you think. I know this video is probably a little bit funky, but I just want to show you, you know, hey, you can do it in another funky way. It's fine. But yeah, thanks for watching. That's all I have for today. Have a great weekend, coming up weekend, and if you're in America, in the United States anyway. I have an Argentinian friend who always gives me when I call it America. But in any case, yeah, and you celebrate President's Day is what I mean. Then happy long weekend, and I'll see you soon. Stay good, stay healthy to good mental health. See you later and take care. Bye bye.